In the early 1950s, the Soviet Union sealed its borders. Traditional human espionage networks were blind, and standard radio intercepts went silent. The United States lost its line of sight into Soviet military planning. Gathering intelligence required sending an aircraft deep into hostile Soviet airspace. That meant finding a way to penetrate the borders without triggering an immediate response from anti-aircraft batteries or interceptor squadrons. This diagram illustrates the physical limits of the Soviet early warning network. They relied heavily on the SCR-270 radar. Because radar waves travel in straight lines, the curvature of the Earth capped its detection ceiling at exactly 40,000 feet. The Soviets did have tracking radars, like the SCR-584, capable of projecting a beam up to 90,000 feet to guide anti-aircraft fire, but the tracking radar had a fatal operational flaw. It consumed so much power and burned out components so rapidly that it was only activated after the lower early warning radar detected an incoming target. This created a mechanical loophole. If an aircraft entered Soviet airspace cruising above 65,000 feet, the early warning wave would never detect it. Because the early warning radar stayed quiet, the high-altitude tracking radar would never be turned on. Ducking under that net meant engineers had to prioritize the math of lift over every established rule of military design. The need for that shift became urgent in 1953, when American attachés spotted a new Soviet heavy bomber, the Myasishchev-4, known as the Bison. Photographs of the Bison triggered widespread panic in Washington. Lawmakers and military officials feared a bomber gap, believing the Soviet Union was building a fleet capable of launching a surprise nuclear strike against the continental United States. The Pentagon demanded an immediate overhead reconnaissance. The U.S. Air Force attempted to solve the problem using the tools they already understood. They focused their efforts on retrofitting their massive, multi-engine bombers with heavy camera equipment. The Air Force awarded contracts to modify existing airframes like the Martin B-57. But because these planes were built to standard military specifications with heavy armor and reinforced framing, their operational ceiling maxed out at 64,000 feet, falling crucially short of the survivability threshold. Military doctrine favored heavy, multi-engine platforms for combat survivability, but these designs created too much drag to reach the altitudes required for a secret overflight. At 70,000 feet, the atmosphere is openly hostile to sustained flight. Air density is so low that the environment resembles a thin, rarefied void. This chart plots altitude against jet engine thrust. You can see the power curve drop to 6% of sea level output as it crosses 70,000 feet. To solve this, Lockheed designer Kelly Johnson submitted a radical design to the Pentagon, the CL-282. To do this, Johnson worked with aerodynamicist Alan Donovan, who realized the only way to balance the equation of thrust and lift against weight using only 6% thrust was to build a jet-propelled glider. Sustained flight at 70,000 feet could not be achieved by adding power. It required a ruthless exercise in subtracting mass and maximizing lift. We can map out this exact solution using Donovan's 3 requirements. Requirement 1, a single jet engine. Using one engine instead of 2 strips out redundant weight and maximizes the aircraft's thrust-to-weight ratio. Air Force doctrine explicitly rejected single-engine designs for missions over hostile territory, demanding a second engine for combat redundancy. Requirement 2, a high aspect ratio sailplane wing. These massive, elongated lungs were necessary to harvest every possible ounce of lift from the extremely thin air. Requirement 3, low structural load factors. The military required combat aircraft to withstand 5.33 G-forces, ensuring the frame wouldn't snap during high-speed maneuvers. Johnson ignored this standard. Designing for only 2.5 Gs, he stripped thousands of pounds of metal from the wings and fuselage. He pushed the weight-saving measures to the absolute limit. He eliminated conventional landing gear, removed cockpit pressurization, and discarded all armor plating. When Strategic Air Command General Curtis LeMay reviewed the CL-282 proposal, he immediately rejected it. He refused to fund an aircraft with no landing gear. Institutional requirements for combat durability had blinded the Air Force to a design that achieved its goal through extreme structural fragility. The project was saved by the Technological Capabilities Panel, a small civilian committee of scientists organized by MIT President James Killian to assess U.S. defenses outside of military bureaucracy. The panel recognized that the CL-282's lack of armor and landing gear, the very traits that made it a poor fighter, made it the only platform capable of reaching 70,000 feet. The airframe alone wasn't enough. The panel sourced the missing payload component from Harvard astronomer James Baker, who was designing high-acuity optical lenses capable of mapping ground details from the stratosphere. This system's architecture diagram illustrates the panel's final proposal, known as Project 3. They fused Johnson's high-altitude glider airframe with Baker's massive optics and placed the entire package under civilian operational control. Flying an armed military aircraft over the Soviet Union risked triggering World War III. By assigning the missions to the CIA, using civilian pilots in unmarked, unarmed planes, the United States minimized the diplomatic fallout. Bypassing the Pentagon's procurement process entirely allowed this small team of civilian scientists to field the world's first dedicated overhead intelligence system. Lockheed built the CL-282 in total secrecy. It was deployed under its new designation, the U-2 spy plane. Flying safely above 70,000 feet, the U-2 pierced the survivability threshold. It mapped the Soviet interior and definitively proved that the terrifying bomber gap did not actually exist. The U-2 is a reminder that when intelligence needs conflict with military doctrine, the laws of physics are the only metrics that truly matter.